All right, for the next part of our unit, we're going to talk about half-angle identities. If you look at the 4 problems that are on this page, you've got 3 pi over 8, 11 pi over 12, pi over 8, 5 pi over 12. And if you notice, none of those denominators are common to what we've been working with. Everything that we've dealt with has been 3, 4, 6, or 2. Pi over 2, 3 pi over 6, things like that. We don't have 8s and 12s. So we've got to figure out a way to deal with it. Now, there's a couple of things. I'm going to actually break this video. I'm going to break it up into 3 different videos. We're going to do sine. We'll do a video on cosine. We'll do a video on tangent. So one of the things you notice is I have off to the side here 3 little formulas. And I literally mean little formulas. These are called the half-angle identities. You do not need to memorize these. These 3 formulas will be on your test. I will pop a formula sheet up into the notes so that you can use that. But understand that I expect you to use these, not expect you to memorize them. I've also done what I always do, which is add this trig chart and then my little ASTC chart. That just helps my brain stay straight with what I need to do. All right. So first thing I want to do is I want to figure out what quadrant 3 pi over 8 is in. 3 pi over 8 would be in quadrant number 1. Now you might be thinking, well, how do you know that? A couple different ways. Mathematically, I could take 3 divided by 8 and I get, I think it's 0.325. That's what my brain is saying. 0.325 would be less than a half, less than 0.5. The other thing I could think of is if I were to, and I'm going to just go ahead and zoom in on this. If I were to start here and go by 8s, this would be 4. Let me try that again. 4 pi over 8 would put me all the way up at pi over 2. I'm not quite there. I'm not, that far. So I know I'm in quadrant 1. Now, why do I care what quadrant I'm in? Well, let me kind of zoom back out here. Let me do a quick copy here. I need this one, so copy that and paste it. Okay, so this is the formula I'm going to be working with. Okay, and if you notice, this formula has a little plus minus in front of it. It's not that there's 2 answers, it's that you have to figure out if your answer is positive or negative. Based off the fact that this is in quadrant 1, and I know in quadrant 1 all of my trig functions are positive, I know that this is going to equal positive stuff. All right, so I'll put that plus sign there for 1, for the first fraction. Then I'm probably going to ignore it because I don't have to put a plus sign in front of things to know that it's positive. I absolutely have to put a negative sign to know that something is negative. All right, so what goes inside the fraction here? Well, it's going to be 1 minus cosine of x, and I'll get to the x in a second, all over 2. Now, x and x over 2, here's the deal. I've got to take this fraction, so 3 pi over 8, all right, so 3 pi over 8, and I'm going to multiply it times a half. That will get me x, all right? So this turns into 3 pi over 4, so cosine of 3 pi over 4. So that's the first start. So if you notice, we've got, and this is half-angle identities are called that because it's half of the angle that we're working with. So the angle that we're working with is going to be 3 pi over 4, and half of that is 3 pi over 8, half-angle identities. Mathematicians, not creative about naming things. All right, so separately, and this is where it's going to get a little bit weird, I now need to figure out what the cosine of 3 pi over 4 is. So if I were to graph it, 3 pi over 4 is over here in quadrant 2, right? This is 3 pi over 4. And in quadrant 2, cosine's negative. All right, it's a s, so that's positive. So what does that mean for this fraction? Well, the whole fraction's positive, so plus, okay, big old square root, 1 minus, now I also know that cosine of 3 pi over 4, whatever this value is, it's going to be a negative value, so negative. Now I'm going to use pi over 4 as my reference. So what is the cosine of pi over 4? Well, that's root 2 over 2. Okay. And that's all over 2. All right, so what just happened here? Well, basically, I just figured out that the cosine of 3 pi over 4 was negative root 2 over 2, and I replaced it into the problem. So I've got a double negative here. Not a huge fan of double negatives, so let's go ahead and make that disappear. I'm also going to stop putting a plus sign in front here because, again, if I just write the radical, we assume it's a positive one. So plus root 2 over 2 all over 2. Now, that does not look like the happiest little fraction in the world to work with. So let's see if we can't clean that up a little bit. Now, right now it's a complex fraction. So I'd like to make it a not so complex fraction. So the denominator that I have here of 2, I'm actually going to multiply that whole numerator times 2 and the denominator times 2. The reason I get to do that is because multiplying by 2 over 2 is the same thing as multiplying by 1, right? 2 divided by 2 is 1. So this whole thing is going to turn into the square root of, well, I'm going to distribute this 2, so it's going to be 2 plus root 2 all over, well, 2 times 2 is 4 in the denominator. All right, now we've got a fraction here that has the radical over it. So I can actually break the radical up into what goes in the numerator and what goes in the denominator. So this could really be rewritten as root 2 plus root 2. I know that sounds weird, but there's actually a root over everything. All over root 4. All right, which just translates into root 2 plus, it's the square root of the quantity 2 plus root 2. I'm going to say it right eventually. And the square root of 4 is 2. So what I want you to be careful about is this numerator, the root goes over everything. And yes, you're going to have a radical within a radical. Oh, well, deal with it. But the denominator is not under the root. So I very clearly stopped the root and then wrote the denominator of 2. So find the exact value. Now, as messed up as this is, sine of 3 pi over 8 has the exact value of this thing in orange. It is what it is, all right? That is the exact value using the half angle identities, all right? I'm going to go ahead and slide on over to number 2. We're going to do the same kind of thing, only this time we've got a denominator of 12. Not that the denominators really change, but it will change your reference angles. All right, so first thing I want to do is figure out what quadrant 11 pi over 12 is in. So thoughts on this. If I were to go by count kind of by 12s, right, this would get me 12 pi over 12, right? That would be pi over here, but I'm not quite there. So instead of going all the way to pi, I'm going to go most of the way there, and that is 11 pi over 12, which is in quadrant 2. Quadrant 2 has an S in it, right? ASTC over here. So this S tells me that sine is positive, which is kind of nice. So this is going to equal positive. Now I can just see the function over here, or if I scroll down a little bit, I can see the sine function here. Remember, that formula is what I want you to be able to use. Please don't memorize it. All right, minus the cosine of, now let's figure out what x is. So I'm going to take 11 pi over 12, multiply it times a half, and that's going to get me, wait a minute, did I do that wrong on the last one? Wow, I did. I have issues. Okay, I need to take a nap apparently. And for any of you who are screaming at the video going, what is she doing? Okay. You're not multiplying by a half, you're multiplying by 2. I'll figure it out eventually. So yeah, just pay attention, ignore the mistake. My apologies. I actually got the right value here. I just did the wrong step. Yeah, to get this original angle, to get half of it, we'd have to multiply this times a half, which we would actually multiply the other side times 2. I have issues. Sorry about that. All right. So no, not going to multiply by a half. I'm going to go ahead and kill that part. I'm going to multiply by 2 here to find 11 pi over 6. That's why I knew I was having some issues. I was going to say that was going to turn into over 24. All right, so the actual value that I want to use from the unit circle is 11 pi over 6. That's a radian measure I can work with on the unit circle. It has a reference angle, all that fun stuff, and that's over 2. All right, so what happens next? Well, next, I want to actually find this cosine of 11 pi over 6. If you want to, write it off to the side here. Cosine 11 pi over 6. All right. Now, 11 pi over 6, let's figure out where that is. So this would be 6 over 6. This would be almost, right? We're in quadrant 4 here because basically we're almost to 2 pi, but not quite there. Quadrant 4 here tells me that I'm in positive cosine world, right? That C down here in quadrant 4 is positive. And I want to use reference angle of pi over 6. So pi over 6 is root 3 over 2. So root 3 over 2. So using this information, I can fill in this. So it's going to be plus. You don't have to write the plus sign if you don't want to. So cosine of 11 pi over 6 becomes root 3 over 2, all over 2. All right, I'm going to take that mess and try and make it slightly less messy. So I'm going to get rid of the complex fraction by multiplying by the denominator of 2. And by the way, the denominator of 2 I'm talking about is this one right here. Underneath, so it's root 3 over 2. It's that one that I'm getting rid of when I multiply through by 2 here. Okay, so this is going to turn into the big old square root, 2 minus root 3 over 4. And then that denominator of 4, I can go ahead and take its square root. Now the numerator isn't going to change, so it's going to be root the quantity 2 minus root 3 all over. And yes, you'll notice I have that denominator, that fraction bar is blocking that radical from going any further, all over 2. All right. So I'm going to go ahead and close the video here because apparently I need to take a nap before I do the next video. But that's how you figure out half-angle identities using for sine. The next video I'll go ahead and pop up should be cosine, and hopefully it has a few less mistakes. But if you have any questions or concerns, please let me know, and hopefully the mistakes didn't throw you off too